In this example, we're going to look at using Dask distributed along with normal Python queues to produce a data processing pipeline on continuous data. So many Dask functions like scatter, map, and gather consume and produce lists. So scatter, you give it a list of local data, it produces a list of futures. Map, a list of local data and a function, or a list of futures, and gives you a list of futures out. And gather, the same thing. These same functions can also consume normal Python queues, and they then return queues as a result, either queues of local data or queues of futures, depending on the function. Because all these functions consume and produce queues, we can use them together to build up single linear pipelines that scatter data out to the cluster, map functions onto that data, and then gather it back. As a quick and simple toy example, we're going to use the local scheduler. So this is running on my local machine. We can see here it's running just on localhost with four cores. And we're going to make a couple of small functions here that will just mimic doing actual work. And we're going to set up our queuing pipeline. So here we've made a standard Python queue. This was imported from the queue module. In Python 2, you'll want to switch this with capital Q. And we're scattering that data out to the cluster. We're mapping the increment function on all that data, doubling all of that data, and then finally bringing the results back to the local machine. So we ran this instantly because there's no data in the queues yet, so there's no work to be done. So both the input queue and output queue sizes are 0. But the whole pipeline is now set up, so we can easily dump a piece of data into the input queue, and it will feed through the rest of the pipeline very easily. So we've seen here we put a piece of data into our queue. Again, this is a normal Python queue. We're just dumping data into it. And we see here that we finished double an increment task. The result, we've gathered already. It's already gone through the entire pipeline and come back home. And we can go ahead and get that result, again, from the normal Python queue. So we took 10, we added 1 to it, 11, we doubled it, 22. So to make that a little bit more interesting, we're going to look at simulating a real pipeline with some asynchronously produced data stream. So this might be, so we're going to use a different thread to dump just a bunch of numbers into our input queue in a separate thread elsewhere. This is simulating, reading data off some instrument or, reading off of a Kafka queue or some other data source. And as we see that as we dump data into our normal Python queue locally, that's being sent out to the cluster, worked on all of our different machines. In this case, just one machine, but it could work just as easily with 100 machines. And the results are being aggregated locally into this output queue. We can go ahead and we can consume our output queue and actually get the results back. And as we see here, it's going to slowly produce more and more results. So we're still fully asynchronous. Everything is free to move along. And this is just a quick and easy data processing pipeline. So as a quick finish, let's just go over things. So we've seen that we can produce a normal Python queue and send that through functions like scatter and map and gather to quickly produce relatively simple data processing pipelines. We simulated an actual data source with a normal thread, but you could have a more involved source. Just a quick disclaimer, this is definitely not a full streaming system, which is a bit more involved. It's just a simple application for a simple case.